Hi everyone, welcome to today's schedule meeting. This meeting is being recorded, so be respectful to each other. We'll be publishing the internet. Okay, let me share my screen. So we have canceled a couple of times. Yeah. The first one was last weekend. I found some potential issues. So I will start with the original bug I found. I give you a heads up. So what I found is that what I found is a kind of regression in 127 because when I upgrade the schedule plugins from 126 to 127, I spot this issue. The issue is that we introduce a skip machinery into prefilter so that for anything that is totally irrelevant with the prefilter plugin, we can skip in a short circuit manner. That is good. And also we, but every prefilter will sort of get wired with a post filter implementation hook, which is the prefilter extensions add pod, remove pod, because that is need to be dry run preemption, right? But some prefilters implementation was relying on reading a pre-calculated state with the particular pre-cycle state key. And that will cause, if the skipped prefilter and doesn't specify that key, and also in the latter case, it specify, it caused the add pod and the remove pod, it will cause issues, cause the preemption totally non-functional. So this is because in 127, if you look at this logic, if a prefilter returns unschedulable, it will just return without setting the skip filter plugin state in this. So we should, the fix was to ensure it's always being executed so that in the latter case, we get rid of this issue. So it happens on 127. We should cherry pick to 177. And this reminds into another discussion with Kensei, which is that this might be a general problem. Let's say a plugin A returns schedule in prefilter, so it gets returned quickly. Then maybe plugin B is placed after plugin A. And then plugin B doesn't have a chance to do its prefilter calculation, as well as maybe there's something to pre-calculate its state, which will be used in the latter case. Yeah, sorry, in the latter phase that is used for preemption. Then once the pod is not schedulable, then plugins B will cause error and then fail the whole preemption process. So this is the general problem I want to bring up today. So Kensei brings up a proposal is that we can say, okay, continue to run prefilter if a plugin returns unschedulable. That means that will be sort of a waste because that is also not aligned with current implementation. That means goes through all the prefilters calculation, no matter it will be used or not. So this is one proposal, and he raised one PR. Yeah, run all filter when the preemption will happen later in the same schedule cycle. I think yeah, go ahead.
I have some questions. So I think there is one bug that affects the kube scheduler, right?
Yes, but fortunately is that all our schedule plugins return unschedulable and unresolvable. So that means that will block the preemption. So vanilla schedule will be good. It just will be.
But I think there was a bug where we were not injecting this status into the nodes when we had unschedulable
Oh,
and
that's
unresolvable.
yeah. That's a second regression. That is also when I and Kensei was discussing about this, and
Yeah.
we are both skeptical about our memory. I do think that unresolvable will block the preemption, but the behavior is not. So we tried to find the regression PR, and that was turns out this is the regression PR. And yeah, this is a third thing I want to mention later. But this is definitely needs to be also cherry picked to 127 and 26. So
this one this one affects vanilla scheduler.
yes, correct. They will affect. That means that totally this semantics doesn't work at all. You will waste some cycles on preemption because okay, the plugin already tells you that this will be unresolvable. Why you spend extra efforts on the preemption, dry run, etc. That definitely needs to be checked.
Okay.
Yeah.
Sounds.
So yeah, so this issue is it's not aggression. It's I would say it's minor issues that might exist in all versions, and because in-tree plugins always return unscheduled and unresolvable, so vanilla scheduler won't be impacted. It's just out of tree plugins. Yeah, Ilya, go ahead.
Hi, I have a slightly related question, but maybe slightly different. So let me know it's not applicable. So this plugin specifically will disallow preemption in scheduler. However, the pod will still can be evicted through the drain, right? So let's say if somebody wants to remove this pod by other means, which goes through eviction and PDB, it will be still evicted, right? So in the sense that the functionality in scheduler and other paths to preempt the pod will be slightly inconsistent. Is that a concern, or is that the issue?
No, that is not the same thing. When we talk about preemption, definitely the pod is unschedulable, right? Because only the pod is unscheduled, it might trigger preemption. So eviction or some other things, yeah, are not in the scope of this discussion.
Right. What I was getting into it essentially when we preempt the pod, the scheduler preemption routine checks for PDBs and checks if the pod essentially should be descheduled, right? So in this case, we will say, oh, right, even though otherwise this pod should be descheduled because it cannot be run anywhere else, we're going to exclude it, which not goes the same way if somebody decides to drain the node, then that pod will be descheduled or removed without reservations of pod schedulability anywhere else. What I'm trying to get to is that those two paths kind of will behave slightly inconsistently with each other, right?
Those two paths. So because we mix too many things here.
Okay, yeah.
Yeah. So let me clarify. Because the regression, if you are talking about the regression that is unresolvable was not honored, then yes, it will impact the preemption pass, because the preemption pass doesn't need to be executed in this case, right? So, but it happens since 126. So that may trigger on some totally unnecessary eviction of the pod. Yeah, you're right. Yeah, that can cause this symptom. Yes.
Sorry,
we
but
can discuss it offline, I guess. I just don't want to sidetrack the whole discussion.
wait, but I think the bigger problem here is not that preemption might do unnecessary preemptions, but rather that it would crash. It could potentially crash, right? Because not all prefilters run.
So again, we are mixing some discussion here. So are you talking about this or
Yeah, unscalable
this
and
one?
unresolvable.
Yeah. So it won't crash, I would say, because once you meet the first unschedulable status, you will return, right? And when you return, then this semantics tells you, I don't want to continue on preemption, but you did. So the symptom is that although it's no totally hopeless for preemption for this part, and still goes preemption, and then it does any maybe unnecessary eviction, but still cannot find a good spot or something. Yeah, that's
Sorry,
the
but preemption works per node. So
yeah.
it needs the status map.
Yeah.
No. It needs the status map, node to status map to be
Yeah,
to
that
have
that
the,
is yeah that is new in this case.
but if we stopped adding the status to the status map, then the scheduler, the preemption would still try to run preemption because, well, there is no unscalable and unresolvable.
Yeah.
And it could crash.
Maybe not crash. Maybe it's just a wasting extra cycles on the preemption. But I haven't confirmed whether it will crash or not. I guess it will not crash. It's just do some redundant efforts because of this. Okay, so yeah, maybe this is confusing you. So basically, this discussion involves two regression. One is that the skip results is not populated. The other is that the unschedulable and the unresolvable is not honored. They both are regressions. And then that's inspired me another discussion is that the difference with unschedulable and unresolvable is that if the out of the tree plugins returns unschedulable, it will stop to block any further prefilters running. And then if further prefilters plugins will rely on their prefilter cycle to do some pre-calculation logic, and then it will be reused in the preemptions logic, like add path, remove path, dry run, and then will be problematic. And this is not big issue, is because all vanilla plugins use the semantics of unschedulable and unresolvable, although that is a regression, but definitely we will fix it. So a more general discussion is that for out of tree plugins or for future in tree plugins that may use unschedulable, what should we do here? So Cassie says maybe we should continue running the prefilter plugins for all failures that is only returns unschedulable, because that is a lightweight error. That means the further preemption may help. So this is one option. The other option is I said here, maybe offer a knob in schedule config to the users choose whether they want to continue run prefilter upon the first unschedulable or not. The other is to try to infer the intention of the user without offering a configuration knob. Basically, we can detect whether a prefilter implements the pre-filter extension or not. So that is the critical part. That is where impact the preemption, because it contains the add path and the remove path section. So that is the thing I want to bring up to a discussion today, or make you all aware of this.
One starting question is, do we have any case already in the
Community?
plugins repo that uses unscalable?
Right now, no. But plugin can be combined. So if we don't support that, we should add a sort of thing like limitations. Says, okay, if you pre-filter returns unschedulable, you may try to only place one this kind of plugin there, right? And then maybe also place it in the end of your pre-filter plugin list. That's the thing we can do. For now, schedule plugins, I think only one plugin, which is called capacitive scheduling, which is the Elastic Coda plugin, implement this. And that is only one that has return unschedulable in the pre-filter. But I need to double confirm with Kensei. Kensei says some of our internal plugins will return this in some very, very edge case. So we will figure out maybe it will impact entry or not.
I would prefer we just do the easier implementation, which is just to continue if it's unschedulable.
Yeah, that will be no OP for entry plugin for now.
Correct, which is fine. And then for out of 3, yeah, I think it makes sense because we don't know if they're like we shouldn't try to check the next plugins. They should be independent.
Yeah, that will be some complex issue because that will happens in the beginning of running all the pre-filter plugins. So you are aware of which plugins has the intent to run pre-filter and some of them doesn't have. Yeah, this is, correct, go ahead.
So I'm one of the engineers on the Apache Unicorn project, which does make use of these APIs. I think the way we use this is we rely on returning unschedulable and unresolvable to ensure that preemption does not occur afterwards. So whatever the solution is, that probably should be. What's that? Well, that's funny you ask, because we just migrated to the latest one on 27. Not that long ago.
Definitely, you will need a patch. Yes, definitely you will need a patch.
So we're not returning just unschedulable, we're returning unschedulable and unresolvable, specifically because we don't want preemption to occur. Currently, we actually have the entire preemption plugin disabled in our configuration.
Okay.
That was actually just, but being able to selectively control that instead of global would probably be preferable. I like the semantics of unschedulable means we might try it, unschedulable and unresolvable means we definitely won't. I think that's a good.
That was a design. It's just a regression breaks this. Yeah.
So we're not currently bitten by this, but if we had taken a slightly different tack, we may have been.
Yeah. Yeah. Okay. I think the conclusion is that both the two regression will be cherry picked. And then for this one, we can just let it soak for a while because it doesn't impact the vanilla scheduler. And also for out-of-tree scheduling plugins, that's very rare case. You have two preferred plugins on the same time return unschedulable. So if you want to understand what's the impact of this general discussion, you can return to this about where and how this can be triggered. So this criteria is still pretty strict, I would say. Yeah, you can take a look. Then Aldo, you have another one. Aldo, could you give a high-level introduction about this?
Yes. So We were I was debugging a customer issue, and we found that, you know, in Kubernetes we have this asynchronous nature. So what could theoretically happen is that you could schedule some pods in a node, user pods in a node, before system pods from a daemon set are created, because of the asynchronous nature, right? And while this is okay for service workloads, sometimes it's not okay for certain applications like gaming, video calls, or certain AI ML frameworks are not very resilient to this kind of preemption. So they need stronger guarantees. Now, these kind of workloads also don't want to be evicted if there is some kind of temporary disruption in a node. So, for example, a node temporarily becomes not ready or unreachable, things like that. These applications don't want to be evicted in that case. So we provide the semantics for not to be evicted, right? That's through, we have this no execute taint and corresponding toleration. So these users use the toleration not ready, no execute, right? Which is supposed to give you this behavior to not be evicted. However, the actual semantics of no execute is that it also restricts scheduling. So if there is a no execute taint, your pod cannot be scheduled. But additionally, if you provide a toleration for this taint, then you are allowed to schedule before a node becomes ready. So,
but hold on a second. I think no execute chain and no schedulable chain are handled differently, separately.
partially. So,
or it's underlying is the override. Like if a node is applied with a no execute, you will definitely given no schedule chain. I didn't check the logic.
So the semantics of no execute is eviction and scheduling, whereas the semantics of no schedule is just the scheduling. So if you have a toleration for no execute, you're tolerating being scheduled early, and you're tolerating not being disrupted, or tolerating, you're tolerating disruptions, or sorry, not being disrupted. Yes. So in a sense, no execute can be think of as a union of, well, rather you can think of no schedule as a subset of no execute.
Yeah, and that is that point I want to raise, because the old semantics is that they are working separately, independently.
Yeah. Right. So you can have tolerations for them separately, but the semantics of no execute is that
superset.
So if there is a taint for no execute and you tolerate this taint, you will be scheduled and you will be exempted from eviction. That's the behavior. What these workloads want is being saved from eviction, but they don't want to be scheduled early. They don't want to be scheduled before the node is not ready. So basically, what they want is system pods to be ready. And only once the system pods are ready, they want to schedule, and once they are scheduled, they don't want to be evicted. That's the semantics they want, and such semantics don't exist today because no execute has this double meaning. So what I'm proposing here at a high level is that we add a new kind of taint, which we can call, let's say, no continue or evict. Then the only effect it has is eviction, and if you tolerate, you would tolerate eviction, but you wouldn't tolerate scheduling. So that would be the API, the new API needed. But then we would need to change the node, how's it called, the node controller, node lifecycle controller, to add this taint for node ready with a no continue effect. But at the same time, we need a taint existing. So we don't. This would what I just said would be a breaking change, right? So we would need to make a no execute taint. Sorry, a no execute toleration to tolerate a no continue taint. So that's the proposal that I have. Maybe I can pause for questions here if you have any.
I'm trying to understand. So if a node is like network partition, and then it's already and it's applied with some system no execute taint, and then suppose your pod wants to tolerate this kind of network partition because maybe you are more certain or you have another integrator to control the high availability of this pod. So you don't trust the system state of those. So you want to tolerate those system automatic add no execute 10. So your pod already carries the no execute toleration. So what you want to add is that if the node is added with no execute taint, you still don't want a new pod that carries the no execute toleration to be scheduled onto this maybe problematic node, right? Is that the intent?
Yes, that is correct.
Okay.
The problem is that we cannot change the behavior of no execute. That will be breaking because you could have, for example, a system daemon set, a user defined system daemon set that needs to be scheduled before the node is ready, or is part of the readiness checks. So there is a valid scenario where you want to both be scheduled and be exempt from eviction. That's a valid use case for system, but these workloads don't want that. They just want to be exempt from eviction, but they don't want to be scheduled early.
Yeah, gotcha. Yeah, Ilya maybe have some idea.
Yeah, I have a clarification question maybe. So if I understand the gist of the issue is that no execute will result in a workload eviction, but it does not prevent new workloads which tolerate no execute to be scheduled, right? Is
So if you have a toleration for no execute, you would
Right.
both not be evicted and you would be, if it's a new node, you would be scheduled.
Right, right, because essentially that's what you want in your workload, saying, hey, ignore this no execute chain for that toleration period, right?
Correct, yes. If there is a period, if there is no period, it's forever, but yes.
Right. So now, if the node also is no scheduled, has taint no schedule, even though I tolerate my pod tolerate no execute and doesn't tolerate no schedule, it shouldn't be scheduled, right? Or maybe it's my assumption.
That is correct.
So right. So normally when node goes not ready, and let's say it's not ready because let's say kubelet died and so forth, usually both taints will be eventually applied. First probably is going to be no schedule because not ready, right? And then followed by no execute after whatever, 5 minutes, right?
It will always, so that's another.
So I guess what I'm trying to clarify is that so for this to be a problem, the workload pod has to tolerate both no execute and no schedule taints on this node, right? Because it only tolerates no execute.
Yes, but the problem is that, that's a good point. The not ready tolerate, the not ready taint is only one and is no execute.
Sorry, I did. So there is maybe I'm not familiar with not ready taint. There is no schedule and no execute effects, right?
Sorry. So let's talk about specifically the not ready taint, not the effect.
Can you clarify what is not ready taint? I'm not familiar with that. It's like
so
is it no execute or no schedule? Which effect we're talking about?
Kubernetes adds certain taints to nodes, and not ready is one of those.
And it only has no execute effect, right?
It only has no execute effect.
Okay, got it. Thank you.
So that is a good point. So if the node, then in this case the node lifecycle controller would add two taints, right? One for no execute and one for no schedule. If the user only has a taint for a toleration for no execute, then still it wouldn't be scheduled. So
Right,
that would
right.
give us the effect that we want.
Okay, so
That is correct.
yes, good. So that's what kind of I'm narrowing down. So if we somehow propose or reframe this conversation, can we add two taints? And if user chose to tolerate only no execute, they won't be able to schedule. However, if they chose to tolerate both no execute and no schedule, then it will be the same thing as effect as today.
Yes. Now the problem is that we still have a backwards compatibility problem here, because if we add this extra taint, there might be system pods that don't tolerate it, and then they would
yeah, for not ready, I think, I believe, if I'm not mistaken again, they always come in pairs. So even though not ready goes to no execute, I think there should be another one, schedule disable on a node. It should have no schedule taint as well, right?
Yeah, so what I'm saying is, yes, we let's say we add two taints to the node.
Well, no, what I'm saying is that we probably don't need to add. So I think when node becomes not ready, it should have both no schedule and no execute right now today. It maybe have different key, I just don't remember off the top.
No, it only has one.
Okay.
Yeah, that's a problem.
I think I had the same understanding. Maybe both me and Elias and Anthony was wrong. Is that no execute and no schedule, the taints are handled differently, and the toleration is handled differently. Just one match. So I'm not sure if I understanding some of our the Kubernetes no-fly sec managers wrong or something, because it sounds to me, well, I may check the code.
So yeah, I'm looking on the notes right now, some of the examples where I see the nodes being not ready. So I do see collection of taints. So you have a node.kubernetes.io unreachable, no execute, then you have node Kubernetes.io unschedulable, no schedule. You have so yeah, you have node.kubernetes.io unreachable, no schedule as well. So unreachable key comes in both no schedule and no execute, right?
If I remember correctly, the no schedule is something that user add, or
okay, maybe
or
right.
it comes from a drain procedure.
Yeah.
If I remember correctly. But
yeah,
go ahead.
Yeah, maybe we should clarify the system semantics first.
Right.
Whether or
I think
not, whether or not the node lifecycle controller will add both taints to that.
Exactly.
Yeah,
And that's what I think
yeah.
would be nice to verify, that we do have this use case where we can have a node with only one no execute taint and not accompanied no schedule taints with the same or different keys.
Yeah.
Right. So the thing is that either adding a taint with the same key or different key that has a no schedule is a breaking change for pods that, let's say for system pods that we're assuming that the only taint is no execute, so they explicitly tolerated no execute.
Yeah, that's what I'm doing. I'm specifically challenging that assumption. From what my understanding is, and could be entirely incorrect, I'm sorry if I'm wasting your time, is that while it is possible to have only one no execute taint, in reality, when nodes goes not ready, become unschedulable, typically they come with a set of taints, one or more, and usually they come accompanied with no scheduled taint with one or different keys. But again, I could be wrong on that, so that's why I'm kind of trying to challenge the assumption.
Okay, I'm not familiar. I will need to double check what happens with the nodes.
Yeah.
No schedule. Sorry, the unschedulable taint, right?
I can also try to do that. I can coordinate node and we'll see what taint's being applied.
Mm-hmm.
Oh,
Okay.
actually, no, it's going to be different. Coordinate does not make not ready. I should be able to reproduce in the kind cluster by stopping kubelet and see what happens on the taints side.
Yeah, I'm also doing some tests here to bring up a node, and because I'm using cork and kill cork, and then the node will be no fake kubelet responding for its heartbeat. But maybe in some time, 1 minute or some time to check this status.
Sometimes it takes up to 5 minutes, I think, default.
Okay, that's fine. I'll report back while the meeting is over. Yeah.
Okay, so I guess I'll update the issue here because yes, you are right that we might already have the semantics that we need from the existing taints. But we need to find a safe way to introduce two taints instead of one if we are to proceed this way. Yeah.
Oh, and also one thing is that not sure if you're using just one single node or several nodes, there's an internal fully disrupted mod that will not apply taint or something that may make the behavior a little different. So for example, here I'm just using one node, and then maybe I won't see the expected behavior because that is controlled by an internal special state called fully disrupted. Yeah, I will report back. I will just use several nodes, and some of them ready, some of them not ready, to see how the taint will apply. Okay, I think we almost used up for today's time. Any other questions?
Nope.
Okay, then I will stop sharing. And thank you everyone for joining today's meeting. I will see you in the next 2 weeks. Thank you
Thank you.
everyone.